we already did. We take the faculty, but now it becomes a little bit more complicated if you do it properly, because you need to take into account for the number of different. So if you have 6 different ones, it's easy. It's the faculty of 6. But what if you have an alignment of 30 and there's a mixture of 4 different amino acids? So you have 10 of one and 5 of the next, and so on. Then you have to take into account the fact that if you have 5 of the same ones, it doesn't matter in which order they are. Yeah. So this is what is the sum over x of nx? So x's are different amino acid types. So what is this sum of? What is this sum then? I'll take this example again. A and F. So if x's are different amino acid types, what is n of x? What is n alanine? It's a bit noisy here, isn't it? So what is the n alanine? 2, right? There's 2 alanines. And the n of phenylalanine. Oh, I have them here. Oh, the other way around. Yeah. 2 alanines, 3 tryptophans, and 1 phenylalanine. Okay. So what is the sum of n? 6, right? It's 3 plus 2 plus 1, but it's just the number of sequences in your alignment. Yeah, this is a constant. So this is our 6th faculty that we had originally. But now, here we have the faculty of X. Okay, I'm going to write this out. So we have 3 plus 2 plus 1 faculty, right? That's the top line in my formula over there. And then, but there's 1 tryptophan, so that's easy, because it's just going to be 1. But then there's 2 alanines, and the first alanine can be here, or it can be there. The second alanine will be in the other place. It doesn't matter if you swap these 2 alanines. So there's 2 options to put the alanines here that we don't care about, because they're going to be in the same place. So that is actually, so you divide this by the faculty of 2 to account for the number of ways in which you can rearrange these 2 alanines. Now we have 3 tryptophans, which you also can rearrange. How many rearrangements of 3 tryptophans are there? There's 3. Faculty of 3, right? There's 3 places you can put the first tryptophan, then there's 2 places left to put the second tryptophan, and there's only 1 place left to put the third one. So that's 3 times 2 times 1. So that's the faculty of 3. And then just to make it complete, for the phenylalanine, there's only 1 option, which is actually the faculty of 1, because there's only 1 place to put it. It could have been 5 tryptophans, then there were more sequences, and then there were 5 faculty ways of reorganizing these 5 phenylalanines. Yeah? So this is 2 faculty times 3 faculty times 1 faculty to account for the fact that we have a couple of similar symbols and we don't care about how you rearrange them. Yeah? So this is all the total number of arrangements that we can have, and these are the ones that we don't care about because they're the same symbol. Now this pi means product, and so this is the faculty of all the x's, numbers of the different amino acids, and the product of those. Yeah? So this is exactly the same. So now you can calculate that. So this works. It's just inconvenient that you first have to calculate these huge numbers and then take the logarithm of that. So the final thing that we do here is there's a very nice approximation, is that you take for the logarithm of a faculty, which you can approximate with, so the logarithm of the faculty of x is, to a fair approximation, x times the logarithm of x minus x. And it doesn't work for small x's, but since we're interested in alignments with fairly big numbers of sequences usually, this is a very good approximation for us. If you work this out, and I wanted to do that on the board, but I don't have time for that anymore. So you can actually, you can take this one, you have to put in the fact that you have to go from numbers to probabilities, and then you can work out that this, using this formula with that approximation, gives you P log P minus P log P, the sum of P log P for all the I. And here the x. So here the x is again the different amino acids that you have in your column. So this way we can actually measure the amount of information content in an alignment column, which actually correlates with the or anti-correlates with the conservation. But now you understand why. Because the situation in the one that I gummed out here, where they're all different, there are just many more ways to get that. So that's least surprising from an evolutionary standpoint. This one, which has few options, is actually very hard to get. So if you get it, something must have happened. Yeah? And we all know what that is. What happened here?
Evolution. Evolution?
Well, random outcome is also the result of evolution. So what? This is the conservation is what we observe. That's the result. So what happened to get conservation?
It's a functional location or structural.
It's a functional location. That's the reason why it happens. But what happened?
Positive selection.
Sorry?
Positive selection.
It's selection, positive selection, right? The reason that this happened is that because if you put anything else here, then a tryptophan or a phenylalanine or an alanine, this is a very unlikely example, but let's put a tyrosine here, that they're all aromatic. If you put anything there except an aromatic residue, you break something, which leads to a decreased survival chance of the organism in which this sequence happens to be. Yeah? It's like a car. If you paint it in a different color, it still drives. If you take out all the seats, it's uncomfortable, but it still drives. It won't sell as much. If you take out one wheel, it could still drive. It's very inconvenient, but if you take out two wheels, you're done. Yeah? It's not going to fly. It's a car. It can fly. It's not going to drive. So that's what happens here, right? You don't see cars with two wheels. Not because you can't make them. They exist. They're in the junkyard. You don't see them on the road. Yeah? Okay. So that's positive selection. I think with that, we've come to the end of part one. Thank you very much again for being here. I think the weather couldn't have been better on a random week in September in Amsterdam. We'll continue in the main building in 08800. Yeah, 8th floor and the big lecture room. Thanks.
Piece of pie. Ja, nee, ik kan dus niet uit dat het is een beetje. Misschien is het wel goed hoor, maar. Fija, la raya, porque ahora dices tú. Is he going to invest for the move for that?